One thing to note when we are simplifying radical expressions is simple equivalences, right? So if I were to multiply the square root of 4 times, say, the square root of 25, well, both of those numbers are perfect squares, right? The square root of 4 is 2, the square root of 25 is 5, and 2 times 5 is 10. But it's also equivalent to say that the square root of 4 times the square root of 25 is the square root of 4 times 25. And 4 times 25 is 100, so the square root of 100 is also 10. Now this is important to note because in some of your first practices you do from this chapter, you are taking numbers like, oh, I don't know, the square root of 75, which is not a perfect square. But we do know that the square root of 75 is the same as the square root of 3 times 25. And that 25 is a perfect square, so we have the square root of 3 times the square root of 25. The square root of 25, that's the same thing as saying 5. So what this is equal to is 5 times the square root of 3. So when we're simplifying radical expressions, this is the first thing we want to be aware of. And how does that factor in when we're looking at something like, say, the cube root of 4 times the cube root of 10? Well, neither 4 nor 10 are perfect cubes, but when I multiply them together, I have the cube root of 40. And now 40 is a much more interesting number because 40, I know, is 8 times 5. And 8 is a perfect cube number. 8 is a cube of 2. So basically I have the cube root of 8 times the cube root of 5, and that would be 2 cube roots of 5. Let's say we make life just a little bit more interesting. Let's try multiplying the square root of 5x times the fourth root of 3y. Well, how do we multiply? See, in the past, we haven't had different radicals. Here we have a different radical. So how do we deal with that? And basically the answer is we use our rules of exponents, right? Let's turn this factor into a rational exponent. So that would be 5x raised to the 1/2 power, while I'm going to multiply that by 3y raised to the 1/4 power. And so now we can deal with this a little more easily. I can understand 1/2 in terms of 4. That's 2 over 4 power. And so what I've got now is 5x to the 2/4 and 3y to the 1/4. They both have a fourth in common, do they not? So I can rewrite these as 5x quantity squared times 3y, and I'll raise all of that. All of that gets risen to the 4th power. Well, 5x squared, now we can simplify just a little bit. 5x squared is 25x times 3y. All of that's being raised to the 1/4 power. And 3 times 25, we can handle that, right? That's 75. That should have been squared. X squared times y. And still, all of that is being raised to the 1/4 power. And so now I can write this, if I needed to write it as a single radical, having multiplied it, I'm taking the 4th root now of the expression 75 x squared y. Isn't that an interesting product? 75, the 4th root of 75 x squared y is all of that. Well, that's all fine and dandy for multiplying. Let's try one where we're factoring. Let's really get interesting. Let's say I want to know what the square root of 216x to the 5th y to the 3rd power is, and I want to simplify that. And remember, let's take a quick look up here again. What we did with that, with something like that, was we had the square root of 75. We had to factor it out into something that was a perfect square number and then remove our perfect square. So let's try and do that with this one here. Let's see. 216, that's a pretty good number. Let's use prime factoring for 216. So 216 is divisible by 2, which is 108. 8, that's divisible by 2, which is 5, 4. That's divisible by 2, which is 2, 7. That's divisible by 3, which is 9, 3, 3, 3, and 1. So 216 is 2 to the third power times 3 to the third power. Well, that's one way to look at 216. But another way to look at it is to see, well, look, I have 2 squared here. And I have 3 squared here. So and then I have left over, I have a 2 and a 3. So this number here, that's pretty cool. That's 9 times 4, right? Well, that's just 36. Okay, well 216 we can understand as 36 times 2 times 3 is 6. And we did that because 36 is a perfect square number. That's going to come out of our radical. Okay. And we can also do that with our x's, right? X is x to the 4th times x. And y is y to the 3rd is y squared times y. All I've done is understand my numbers in terms of their perfect square components. So the square root of 36 is 6. The square root of y to the 4th is, x to the 4th is x squared. And remember what that means is x to the 4th, when I want to know the square root of that, that's x to the 4th raised to the 1/2 power, or x to the 4 over 2, which is just 4 divided by 2 is x squared. That's how that all reasons its way out. Right? And I just did that in my head. And so we're left with an x underneath the radical. Y squared is y. The square root of y squared is y. So underneath the radical I have left over, that came out as 6. That came out as x squared. And that came out as y. So I'm left with 6, x, and y.